Hello, welcome back to Cracking the Cryptic, where we're going to do another of our short videos taking a look at Killer Sudokus, in particular the greater than Killer Sudoku variety, and just talking about how to make progress to start one of these very difficult puzzles that appear on websites such as dailykillersudoku.com. So how do you get started on this one? This was yesterday's 8 out of 10 rated puzzle. The average solve time is about an hour for this puzzle. So if you fancy your chances, go to the website and take a look and see how you do. It's not easy, I will tell you that. You can see this 17 cage, that can only be 8 and a 9. And the first thing you have to do to make progress here actually is to look at the geometry of the grid. Now, we can see, for example, if we look over here, we've got a 12 cage and a 21 cage. That adds to 33. So we know these two cells sum to 12. Now that's interesting because you can immediately see there is a relationship between this cell's value and this cell's value. What do I mean by that? Well, let's just pick a number for this. If this was a 3, then these 4 cells would have to sum to 26. Well, 26 plus 22 is 48, so we've already got too much in this box. So we're going to have to make this number bigger in order to make the value of these 4 cells smaller. So let's try 7, for example. 7 would give us 22, 22. That would make this a 1. That's possible. So 7 is the absolute minimum this can be. 8 and 9, therefore, would give us 2 and 3 here. But remember that whatever we make this cell, we have an implication for this cell. So if this is 7, this will be 5. Similarly, 8 will give us 4, and 9 will give us 3. So you should immediately be thinking, oh, hang on, when this was 9, didn't that make this a 3? And yes, it did. So there's already a nice contradiction that we find. When this cell is 9, this cell is forced to be 3, and this cell is forced to be 3. So that gives us our first ability to eliminate an option in a reasonably tricky situation. Now we can do the same trick we were doing over here with this cage now. So you can see if we make, whatever we make this cell, it's implying something for the value of this cell. So what can we see from that? Well, if this is a 4, that means this is going to be 23. 23 plus 17 is 40, so that would be a 5 here. If this is a 5, it's going to be 5 or a 6. I'm continuing the logic, so let's take an example. If this is the 5, and therefore this square here is a 6, well, we know this, in that situation, this is a 7, and this is a 1. So 6 and 1 is 7, so that would make this one a 6 as well. Well, that's not possible. We'd have a repeated 6 in this 13 cage. So in fact, we can deduce that this must be like that. 5 and a 2 here. Now, and in order to do that, we need this to be a 4, and then this would be an 8. Now, the next step in this is really rather lovely. And again, it's not desperately easy to spot. But have a pause of the video and see if you can see a way of making progress here. I really like this next step. And it's one of the things I admire about this website in general, is that the puzzles, I think, have a very linear structure to them. You know, there's a nice spot that you can make that leads you to the next number. And if you don't spot it, you can be staring for hours, literally hours, trying to find the next way to make progress. But here, again, there's something very sweet we can do. So you need to focus on these numbers, 2 and 4, that we've just found. And we need to think about how they interact on this 3x3 block. And the interesting thing is that the 2 and the 4 are therefore going to be forced to be in this 7 and 9 cage. Now if we add the 2 and the 4 together, we get 6. So we know that the 2 and the 4 are not in the same cage, therefore they must be in different cages. But what happens if we put a 2 in the 7 cage, for example? If we put a 2 in the 7 cage, this would be 2 and 5. We know there must be a 4 then in the 9 cage. Oops, we get a clash. So we cannot put the 2 in the 7 cage, because the 4 we'll then have to put in the 9 cage will give us a problem. We'll get a repeated 5 in the grid. So what can we tell therefore? Well, therefore the 4 must be in the 7 cage, and the 2 must be in the 9 cage, and there we go. So we get this configuration instead. And now you can see the 8 and the 8 here. And there must be an 8 in there, and these numbers now can only be 1, 5 and 6, and we can use the greater than signs here, I think, to make another deduction. This is 12 here, so it's greater than a 2 cage here, so this could be 11. That's the maximum this could be, and therefore the maximum this could be would be 10. It can never be 11, so these two cells can never be 5 and 6, which means this cell cannot be a 1. So we can eliminate the 1 there as an option. And ways to make progress from here might be, we could look at these numbers or look at this 21 cage. So you can see this 5 here means there's not a 5 in one of these two positions, and we've just got this 1, 5, 6 triple over here, which means there's not a 5 basically in this 12 cage. Therefore there is a 5 in this 21 cage. So the options left here that contain a 5 are going to be these, but we mustn't have an 8, so we can eliminate those two, look, and we mustn't have a 4, so we can eliminate that one as well. But we can resolve this by thinking about this 2, because we can therefore see there's no 2 in this block, so there must be a 2 in this 12 cage, which means it must go here, which means these two have to add up to 10, which means they can be 1, 9 or 3, 7. Well, they can't be 1 and 9 because we already have a 1 over there in one of those cells, so this is going to have to be 3 and 7, and therefore this one is ruled out. So we get 1, 5, 6, 9 in this top thing here. Those can't be 9. 9, 9, which means these two are 9. Therefore these two have to add to 5 and must be 1 and 4. And we have 4 over here, so that's a 1 and that's a 4. Remove the ones over here, look. And these are going to be forced to be the balance. That's 3, 5, 6 and 7. So again we can put the 3 down here. 6 and 7 like that, and remove the 6's. And from here you can think about things like, where can an 8 and a 9 go in this column now, or even where could a 1 go, and you can begin to build up progress from there. But I'll leave that as an exercise for you guys, just as to say, a short video today to reflect on another of these excellent Killer Sudokus, and we'll see you again next time on Cracking the Cryptic.